The second part of today's notes involves finding the sum of the first n terms of an arithmetic series. The formula is given, but before I showed you how to use the formula, I wanted to show you where it came from. There's this story in mathematics that talks about a mathematician who we call Gauss and how his teacher was upset with him. So his teacher said, I want you to add the first 100 numbers together as punishment for something that he had done in class. I know, math for punishment. Isn't that crazy? Who would ever think to punish someone using math? But anyway, Gauss sat there and right away came up with the answer and just shut the teacher down. And she was shocked and was like, how did you find the answer so quickly? But what he did is he noticed a pattern. If I said add the first 10 digits together, you guys should see that if you add the first and the last number, you get 11. If you add the second to last number on each side together, you're going to get 11 as well. And if you keep going, you should notice that you keep getting the sum of 11 for all of these different pairs that you add together. Now, if you think about that sum of this first and last term being 11, that's where this part of the formula comes from. Now, if you think about how many times we're going to add 11 together to add these all up, this is really 11, a total of 5 times. So the answer for this, if I said add 1 through 10, all of those numbers together, the answer is 55 because you're getting 11 a total of 5 times. Now, that's exactly what this formula says. If you notice, you're adding the first and the last term, and you're going to get that sum dependent on the number of terms you're adding together divided by 2. Now, why is that the case? I added 10 terms together, but how many sets of 11 did I get? Only half of that amount. So that's why you take that n value, however many terms you're adding up, and divide it by 2, and then multiply that by the sum of that first and last term. So it's kind of cool. I hope that makes sense to you. If not, it's not important. Obviously you need to know how to use the formula, but you can still use the formula without completely understanding that. But I just thought it was kind of cool to show you that. So anyway, this is how you use the formula. You're going to be asked to find a specific partial sum. In this case, it says the 10th partial sum. When you are asked to write the sum or find the sum, we, instead of using an A to start the formula, we use an S, and then the little subscript is the number of terms you're going to be adding together. So if I said the 10th partial sum, you're going to take the first 10 numbers of this sequence and you're going to add them all up. Now, in order to use this formula, it has to be an arithmetic series or sequence. A series is when you actually add them together. Notice what was given as a sequence, but we're going to be adding these together. So in a sense, it does become a series. Now, if these have a common difference, we can use this formula. So if you notice, to go from 8 to 26, or from 26 to 44, or 44 to 62, we have to have the same number. And I'm thinking it's 18. So we can check to see that for each of these, you're adding 18 to get to that next term. If this is the case, remember I said we have this common difference of 18, this is arithmetic. So what we can do is we can use this formula. So if you want to find the sum of the first 10 terms, remember this idea of how many different sets of that sum are we going to get? It's going to be 10 divided by 2. You're going to get 5 sets of the first number, which in this case is 8, plus whatever the last number of this set would be. Here's the problem. They only gave us the first 4 numbers of this set, and we need the first 10 numbers. Now, I'm not going to ask you to keep adding 18 until you get to that 10th number, because that's really what we want here, is we want whatever that 10th term is. Instead, we're going to find this right here using the first formula that you learned. If you ever want to find a specific term, remember the formula that you learn on the first page is that we need to know the first term, which in this case was 8, and then we're going to add to it n minus 1 times the common difference, which in this case is 18. Now, what is our n value? Because we want to find the 10th term, n is equal to 10. So what we can do is we can simplify this. 10 minus 1 is 9, and we can use our calculator here to find what that 10th term would be. So going to my calculator, I'm going to do 8 plus 9 times 18, and that's going to give me what my 10th term is. Once I find my 10th term, then I can fill that in for a sub 10. Now, to simplify this, you can do the math. I can get my calculator back out. But you can do the math that 10 divided by 2 is equal to 5. And then 8 plus 170 is 178. And then we can multiply that together. 5 times 178. And I'm getting this value of 890. And then that would be the sum of those first 10 terms. So again, my screen just froze, so let me get this back out. So if you were to write all 10 of those numbers and you connected the first number with the last number, you would see that the sum that you get every single time you connect is 178. So if you do this with all 10, notice that you would have 5 sets of 178, thus getting that sum of 890. So the next problem is, again, finding the sum. And notice that this is an arithmetic series that we're talking about. And I know that because this is a linear equation. You will notice that every single time a linear equation follows a sigma, it's arithmetic. Why? Because going back to the formula, notice that every single time we use the formula, if it's arithmetic, you are getting a linear equation as your final answer. So if you have a linear equation to the right of the sigma, that means you're talking about an arithmetic series. Now, if I want to find the sum, the first thing I need to do is think about how many terms I'm finding the sum of. I'm going to sub in a 1, a 2, a 3, a 4, and keep doing this all the way up until 84, and then I'm going to add all those terms together. Woo! You would never want to do this by hand because that's a lot of terms. I would never ask you to do this by hand because obviously there's got to be an easier way. So with that being said, you're going to use this formula. Now, for this formula, we first need to find out what is our n value. Be careful here. I want to go back to the beginning part of the notes when you were asked to find the sum of question number 2. Note that there was 5 total terms that we added together because our counter started at 1. We subbed in a 1, a 2, a 3, a 4, a 5. A lot of people think that when you are doing a sigma, the number of terms you're going to sub in is the top number minus the bottom number. But note, that would only be 4 terms, and we need a total of 5. So you're going to see that whenever you're given a problem like this, you're not going to take the top number and subtract the bottom number because that wouldn't give you enough. If you ever want to find n, you can take the top number and subtract the bottom number, but you always want to add 1 to that quantity in order to get what your n value would be. Now, I know you may be saying, wait, that's confusing. Isn't it just going to be the top number? It's not. If you go to question number 7 and I said, how many terms is this? Right away, some of you might be saying, that's 14, but it's not. Actually, this is representing 15 terms. You're going to do the 34 minus the 20. That's 14, but then you're going to add 1 to that quantity, and this is actually 15 terms. To show it to you a different way, let's just say I had a sigma, and at the bottom I had n equals 0, and at the top I had 1. You would have to sub in a 0, you'd have to sub in a 1. That would actually be 2 terms that you're finding and adding together. But if you subtract these, that only equals 1. So you have to add 1 always to the difference of those 2 numbers. I know that that's very tricky, but just make sure whenever you're finding the number of terms and there's a sigma there, you take the top number minus the bottom and then add 1 to that. So basically, you're going to always take the upper limit minus the lower and then add 1. Same thing here. You're going to take the upper number minus the lower number and then add the 1 always. Okay? So that helps us to find the number of terms. After you find the number of terms, remember for the formula, we need the first term and we need the last term. To find the first term, you're always going to take the number at the bottom and sub that in, because that will be the first term of this specific series, no matter what. Even if that number's not a 1, you're going to take that and sub it in, and that will be the first term of this specific series. So with that being said, to find the first term, your a sub 1 here, your a sub 1 is going to be when k equals 1, and what we're going to get for that is 3 times 1 minus 7, or a value of -4. Same thing with this one down here. But to find your a sub 1 term, it's really going to be when n, let me not use an equal sign there, because I'm going to have a lot of equal signs. Hello. Okay, I guess I'm not going to erase. I'll just write over that. N equals 20. And that would be the -2 times the 20 plus the 3, or the -60 plus the 3, the -57. Oh my goodness, this froze again. Why does this keep freezing? It's kind of annoying. Sorry, guys. All right, so going back, we found our first term. Now, to find your last term of this, because remember, a sub n is the last term. Okay, so the last term that you want to add for this specific series. The last term is when you sub in the top number to that formula. So to find my a sub, in this case, 84, I'm going to sub in k equals to 84. And that means that I'm going to do 3 times 84 minus 7 in order to get my last term of this. So 3 times 84 minus 7, I'm getting 245. In the question number 7, to find your last term, you're subbing in a 34. So you're going to find a sub 34 by subbing in n equal to 34. So we're going to do -2 times 34 plus the 3. And then let's do this by hand, -68 plus the 3. We get a -65. Now, we found the numbers we need. Let's just get our final answer. If you want to find the sum of 84 terms, which this problem's asking you to do, you're going to take 84 divided by 2, and then you're going to multiply that quotient by the sum of -4 plus the 245. To do the problem number 7, you're going to find the sum of 15 terms. Same thing, you're going to take the number of terms divided by 2, and you're going to multiply that by the sum of -57 and -65. So let's use our calculator for this. So if we do the 84 divided by 2, that's 42. And then if I do the -4 plus the 241, or 245, that's 241. And then we could do 42 times 241. And I'm getting 10,122. Which, of course, we'd expect that to be a lot. I mean, it's growing by 3. You're multiplying by 3 and then subtracting 7. So you will see that growth in there. Think of a linear function that is increasing, by a slope of 3. And then for this one right here, we get 7.5. And then we're going to add these two numbers together. And I'm getting -122. And then I can multiply that by the 7.5 to get this answer of -915 as my sum. All right, so we're almost done. I know this has been a lot of notes, so I appreciate your patience, especially if you're still listening. Question 8 is the final one, and then there's problems for extra practice. After I finish question 8, I will pause the video. You can do the extra practice, and then you can come back on and check the work that you got, the answers that you got with my answers. So finally, number 8. It says a small college lecture hall has 20 seats in the first row, and each row has 2 more seats than the preceding row. Find the total number of seats. I'm going to star that. In the hall, if there are 30 rows. So let's start by writing out our series. I have 20 in my first row. And then each row has 2 more. So that means the next row would have 22. The next row would have 24. The next row would have 26. And this would keep on going until we got to the 30 row of seats. So this represents my A sub 1. Now, my common difference is that I keep adding 2 to get to the next row. So we have A sub 1 equaling 20, and then I have my common difference equaling 2. I have enough information to write my rule to find the number of seats in any row. If you think about it, we have our first term of 20 plus n minus 1 times the common difference of 2. If I simplify this, I get my rule for finding the number of seats in any row. Notice when I sub in a 4, I should get 26, and notice that if I do that, I get 26. Now, let's answer the question. We want to find the total number of seats if we have 30 rows. So that means I'm finding the sum of all 30 rows. Well, if I fill into the formula, I have my n value divided by 2, and then I need to know the number of seats in the first row, which was 20, and then I also need to know the number of seats in the 30th row. You may have asked or questioned why I was setting up this rule for the first part of this, and this is why. If you want to find the number of seats in the 30th row, the last row, we have to use this formula I just created. If you want to find A sub 30, we need to sub in a 30 for n to find out how many seats are in that last row. So notice I would get 60 plus 18. I'm getting 78 seats in that 30th row. You're going to see on a quizzes that you do later on that I'll ask you how many seats are in the 30th row and then how many seats are in the whole auditorium. So this would be the answer to how many seats are just in that row alone. And then the second part of this answer would be filling in this value of 78 and then finding the total number. So if I simplify, I have 30 divided by 2, 15, times 98. And then I can use my calculator to find what that quantity is. 15 times 98, I'm getting 1470 as my final answer. So that concludes today's notes. There is Delta Math for you to complete. Before doing that, though, you might want to do the extra practice. So at this time, feel free to pause the video, do the extra practice, and then come back when you're done to check your answers. All right, if you have finished the extra practice, here are the answers and all of my work. Feel free to pause the video, check my work against your work. Let me know if you have any questions. Just a brief rundown for number 9, they wanted you to find the sum of the first 40 terms, but the sequence was defined recursively. Whenever this happens, start writing out your sequence by doing what we did when we learned about recursive formulas. To find the second term, you're taking the first term and subtracting 4. To find the third term, you're taking the second term and subtracting 4. To find the fourth term, you're taking the third term and subtracting 4. So what you'll see is that to get to each term in the sequence, we're subtracting 4 each time, which becomes our common difference. So if I said find the first 40 terms, you're filling a 40 for n. The first term was given to us, but to find that 40th term, just like in the last problem, you have to use that rule formula. If you want to find the 40th term, you need to know the first term and the common difference, and then we can sub in a 40 for n, and that gets us the number of, I was about to say seats, but that gives us that 40th term for this sequence. And then notice from there, we can fill that in to find the sum of all 40 terms. Note it is negative, and a pretty big negative number, because think about how this sequence is decreasing as time goes on. It keeps subtracting 4 for each term. Looking at the second problem, here's one where you have to be careful. If I said find the sum, the number of terms is the top number minus the bottom number, but then you have to add 1. So this is really the sum of 34 terms. To find the first term, you sub in the bottom number. To find the 55th term, you sub in the top number. And then from there, you can fill into the formula to find that solution. The final problem, if you ever don't know what to do, start writing out the sequence or the series for this. If I want the sum of the first 500 multiples of 7, write a few multiples of 7. 7, 14, 21, 28. Think about how your common difference here is 7. And if you want the first 500 multiples, that's the first 500 terms. So your n value becomes 500. The first term was 7. And then if you want to find that last term, you have to create that rule formula and then find what the 500th term is by subbing into that first formula that we found. That will get you that final answer. So a lot of notes today. Take your time to digest this. This is everything you need to know for the week. The rest of the week, you're just going to be practicing this.